Hello, in this lecture we'll answer two questions. In the first question, we'll find out the radius of this quarter circle. In the second question, we will find out the size of this angle, angle theta, that is inside triangle ABC. So we'll start with the first question. In the drawing, we have a quarter circle. Inside the quarter circle, line segment BC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units. This angle OBC equals to 90 degrees, this angle BCD equals to 90 degrees, and this angle CDL is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so because of the fact that this is a quarter circle, I can conclude from it that point O is the center of the quarter circle, so I write it down. Point O is the center of the quarter circle. And angle BOF, this angle equals to 90 degrees. And actually, side AO equals to side OF, and they are both the radii of this quarter circle. So we'll define the radius of this quarter circle as R. Therefore, the length of side AO will be equal to R, and the length of side OF will be also equal to R. It is also the radius of this quarter circle. So in the next step, we will extend the straight line CD by a straight line until it touches the side OF, or the radius OF of the quarter circle. And we will define the touching point of the extended straight line CD and OF as point M. So actually, by this construction, we created here quadrilateral BCOM. And inside quadrilateral BCOM, we have 1, 2, 3 right angles. Okay, so here I write it down. Here quadrilateral BCOM. Inside quadrilateral BCOM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle CMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation. And we will get that the missing angle, angle CMO, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the missing angle, angle CMO, is a right angle, is equal to 90 degrees. So I can write here that angle CMO is equal to 90 degrees. So actually, inside quadrilateral BCOM, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate quadrilateral BCOM as a rectangle. So I write it down. Quadrilateral BCOM is a rectangle. Why? Because it has 4 right angles. Okay? Quadrilateral BCOM is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle BCOM, side BC must be equal to side OM. Side BC equal to side OM according to the rule that the opposite sides of a rectangle are equal to each other. Okay. But according to what is given as the equation, side BC equals to 9 units. So you can write down that BC equals to 9, and from this equation 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. OM equals to 9 units. And here we extended the straight line CD by straight line, and the result is CM. When we extend the straight line by straight line, the result must be a straight line. Therefore, the result that is CM must be a straight line. So I write it down that CM is a straight line. Line segment CM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is a straight line, and if we focus on the upper side of the straight line C at point O, here the sum of the angles must be equal at point O to 180 degrees. So alpha plus beta must be equal to 180 degrees. The sum of the angles on the upper side of the straight line CD at point O must be equal to 180 degrees. Therefore alpha plus beta must be equal to 180 degrees. So we actually can implement rule number 3 in our drawing, because in our drawing we have here the straight line CM. So if you focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at this side of CM at point D? We have here this angle that is equal to 90 degrees, plus this angle that is equal to angle ADM. In total, the sum of those two angles must be equal to 180 degrees. Okay. So here we subtract 90 degrees from this equation, and we get that the missing angle, angle LDM, is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So the missing angle is a right angle. It is equal to 90 degrees. So I can write here that angle LDM equals to 90 degrees. It is a right angle. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So we can write down that OF is the radius of the quarter circle, is a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees. So each angles we have on the upper side of OF at point M, we have here 90 degrees plus angle DMF, this angle. In total, the sum of those two angles must be equal to 180 degrees. So here we subtract 90 degrees from this equation and we will get that the missing angle DMF is equal to 180 degrees minus 90 degrees, it is equal to 90 degrees. So this angle DMF equals to 90 degrees. In the next step, from point L, we will draw perpendicular on the radius OF. Repeat again, from point L, we will draw perpendicular on OF. We define the touching point of the perpendicular from point L and OF as point N. So, by doing this construction, we created here quadrilateral DLMN. And inside quadrilateral DLMN, we have 1, 2, 3. Actually, before that, we drew perpendicular on OF, therefore this angle equals to 90 degrees according to our construction. I repeat again, we drew perpendicular from point L on OF, therefore this angle equals to 90 degrees according to our construction. So now we can see that inside quadrilateral LDMN we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle DLN. This angle, in total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. The sum of 3 right angles plus the size of angle DLN in total must be equal to 360 degrees. So here we subtract 90 degrees, 270 degrees from this equation, and we get that the missing angle DLN is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the fourth angle, it is a right angle. It is equal to 90 degrees. So here, this angle, it is a right angle. It is equal to 90 degrees. So actually, we found out that inside quadrilateral DLMN, we have 4 right angles. Repeat again, inside quadrilateral DLMN, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. Repeat again, quadrilateral DLMN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DLMN must be equal to each other. We'll define side DM as edge. Here side DM equals to edge according to our definition. And according to the rule that the opposite sides of a rectangle are equal to each other, we get that DM equals to Ln. DM equals to Ln. Repeat again, DM equals to Ln, but according to our definition, DM equals to h. So you can write here that DM equals to h. And from this equation, h equals to DM equals to Ln, we will derive that Ln is also equals to h. Ln is also equals to h. Here I can write down that Ln equals to h. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we'll get that side DL must be equal to side MN. DL must be equal to side MN. Repeat again. Side DL must be equal to side MN. But according to what is given us in the question, side DL equals to 12 units. So I can write here that DL equals to 12 units. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Okay, side MN is also equals to 12 units, so we can write down here that MN equals to 12 units. We'll focus on triangle PCOM. Here we have already found out that side OM equals to 9 units, but I didn't write it on the drawing, so I write down that OM equals to 9 units according to what we have already found out. Therefore, ON, line segment ON, is equal to OM plus MN. That is to say, ON equals to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21. So here, ON equals to 21 units. And you can see it from the drawing that points F and N are very close to each other. And OF is the radius of this quarter circle. Therefore, we expect that the radius of this quarter circle will be a little bit longer than 21 units. Why? Because ON equals to 21 units and OF it is a little bit longer than OM because points F and N are very close to each other. So we are expecting that the radius of this quarter circle that is equal to OF will be a little bit longer than 21 units. Okay? So in the next step, we will join points O and C together by a straight line. Here point O is the center of the circle, of the quarter circle. Point C is the point of the quarter circle itself, therefore OC is the radius of the quarter circle that is equal to R according to what is given us the question. So in the next step we will implement the Pythagoras theorem on the right green triangle, triangle OMC. So here by PT is the abbreviation for Pythagoras theorem. In the right triangle, triangle OMC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, the hypotenuse is OC, therefore the square of the hypotenuse is OC square. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to OM square plus CM square. Repeat again, for the Pythagoras theorem on the right triangle, triangle OMC, OC square must be equal to OM square plus CM square. Here OC equals to R, therefore OC square will be equal to R square, and it is equal to OM square. OM equals to 9, therefore OM square is 9 square, that is 81. Plus CM square. Here CM equals to CD plus DM, that is to say CM equals to CD, that is 16, plus DM, that is H. So in total CM equals to 16 plus H. If CM equals to 16 plus H, it means that CM square is 16 plus H square. So in total, in conclusion, we found out that according to question number 1, R square equals to 81 plus 16 plus H square. Here we'll open the brackets on this side of equation number 1, and we will get that according to equation number 1, R square equals to 81 plus 16 plus H square. We'll open the brackets here. 16 plus H square equals to 16 square, that is 256, plus H square, plus 2 times 16 is 32, times H is 32H. Okay. So according to equation number 1, we found out that R square equals to 81 plus 256 equals to 337 plus H square plus 32H. Okay. In the next step, we will join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, OL is the radius of this quarter circle that is equal to R. So, in the next step, we'll implement the Pythagoras theorem on the right orange triangle, triangle LON. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is LO, therefore the square of the hypotenuse is LO squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to LN squared plus ON squared. I repeat again. According to the Pythagoras theorem, in the right triangle, in the right orange triangle LON, LO square equals to LN square plus ON square. So LO equals to R, therefore LO square is R square. That is equal to LN square. LN equals to H, therefore LN square is H square plus ON square. Here ON equals to OM plus MN, that is to say ON equals to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21. So ON equals to 21, therefore ON square is 21 square. So in conclusion, we found out that according to equation number 2, R square equals to H square, and 21 square is 441. So in conclusion, according to equation number 2, we found out that R square is H square plus 441. While according to equation number 1, we found out that R square equals to 337 plus H square plus 32H. So in the next step, we will create equation number 3. That states that R square according to equation number 1 must be equal to R square according to equation number 2. Read again. According to equation number 3, R square according to equation number 1 equals to R square according to equation number 2. So R square according to equation number 1 is equal to 300 337 plus H square plus 32H, and it must be equal to R square according to equation number 2 that is equal to R square according to equation number 2 equals to H square plus 441. Okay. So here in equation number 3, we have h squared on both sides of the equation, so h squared will get cancelled. So what is left from equation number 3 after we cancelled h squared? What is left is that here, this side of the equation, we have left with 337 plus 32h. This is equal to 441. Here we'll subtract 337 from this equation number 3, and we get that according to equation number 3, (32h) equals to 441 minus 337 is 104. So according to equation number 3, we found out that 32h equals to 104. So here we divide the equation number 3 by 32 and we get that h equals to 104 over 32. So found out that h equals to 104 over 32. That is to say h equals to 3.25 units. In the next step, we substitute h in equation number 2 by 3.25. Okay. According to equation number 2, we found out that r squared equals to h squared plus 441 so if h equals to 3.25, it means that h squared will be equal to 10.5625. So h squared is 10.5625. So r squared equals to h squared plus 441. It means that is to say r squared equals to 10.5625 plus 441. So r squared, according to equation number 2, r squared equals to 441 plus 10.5625 equals to 451.5625. Here we take a root out of this equation, equation number 2, and we get that r equals to the square root of 451.5625. It is equal to 21.25 units. Okay, so I actually found out that the radius of this quarter circle equals to 21.25 units, while we already found out that ON equals to 21 and OF equals to 21.25 units. So the difference between side ON and the radius OF is only 0.25 units. They are very close values. Okay, so finished with the first question. In the next step I present to you the second question, and we will answer on the second question in two different methods. So in the drawing we have triangle ABC, side AB equals to x plus y, side AC equals to y, side DC equals to x, angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, and our mission is to find out the size of this angle theta that is actually also equals to angle ABC. Okay, so in the first method we'll do a construction. We'll extend side BC in y points, in y units. Okay. So we define this point as point E. So here CE equals to y units according to our construction. In the next step we'll join points A and E together by a straight line. So here we create the triangle ACE. I will copy triangle ACE in a new page and we will analyze triangle ACE. Okay, so we'll copy triangle ACE and we'll analyze triangle ACE. So actually this is triangle ACE that I copied from the original drawing. Here side AC equals to y and side C equals to y, so therefore side AC equals to side CE, and here those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles, so in front of this side we have this angle, in front of this side we have this angle, so those two angles must be equal to each other. So here we can write down that angle CAE must be equal to this angle, angle AEC. Those two angles must be equal to each other. So if we define angle CAE as alpha, here angle CAE equals to alpha according to our definition, then from this equation alpha equals to CAE equals to AEC, we derive that angle AEC is also equals to alpha. This angle AEC also equals to alpha. Okay, we derive that the angle AEC is also equals to alpha. In the next step, I will copy angle ACB that is equal to 40 degrees. I will copy it here to this drawing. So this angle ACB is equal to 40 degrees according to what is given as the question. And I also present to you the I present to you the external angle theorem. According to the external angle theorem, if we have triangle ABC that could be any triangle, this is triangle ABC. This angle equals to alpha, this angle equals to beta, and this angle equals to gamma. So here angles alpha, beta and gamma are defined as interior angles of triangle ABC. Interior angles. While this angle angle ACD is defined as an exterior angle. So angle ACD, we define angle ACD as E, that is equal to A, is defined as an exterior angle of triangle ABC. And the reason that is defined as an exterior angle because of the fact that it is located outside triangle ABC, while the other angles are located inside triangle ABC, therefore they are defined as interior angles of triangle ABC. So according to exterior angle theorem, the size of the exterior angle E equals to the sum of the two interior angles that are not adjacent to it. Angle gamma is adjacent to angle E, and the two other interior angles that are not adjacent to it are alpha and beta, and the sum of those two angles is alpha plus beta. So In conclusion, we found out that the size of the exterior angle E is equal to alpha plus beta. So this is the exterior angle theorem. Actually, it tells us what is the size of an exterior angle of a triangle. We will implement the exterior angle theorem in this triangle ACE. Here the two angles alpha and alpha are defined as exterior angles. Angle ACB, this angle ACB, is defined as an exterior angle. So the size of the exterior angle ACB will be equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to angle ACB, therefore the two other angles that are not adjacent to it are alpha and alpha. That is to say, ACB equals to alpha plus alpha. Alpha plus alpha is 2 alpha, and angle ACB equals to 40 degrees according to what is given us the question. So from this long equation we can derive that 40 degrees equals to 2 alpha, or 2 alpha equals to 40 degrees. We divide this equation by 2 and we get that angle alpha equals to 40 degrees over 2, that is 20 degrees. So we found out that angle alpha equals to 20 degrees. Here. So we can write down here that angle CAE, that is equal to alpha, is equal to 20 degrees, and this angle AEC, that is also equal to alpha, it is equal to 20 degrees. Okay. If we focus on triangle ADC, in triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees, and the sum of those two angles, 80 degrees plus 40 degrees, is 120 degrees. So if the sum of two angles in the triangle is 120 degrees, it means that the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees, it is equal to 180 degrees. It is the sum of the angles in any triangle. Okay, so this angle must be equal to 60 degrees. Okay, so in the next step, I will copy triangle ADE in a new page and we will analyze triangle ADE. Angle DAE equals to 60 degrees plus 20 degrees, it is 80 degrees. And what is the length of side DE? The length of side DE, it is equal to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in conclusion, DC equals to X plus Y. DC equals to X plus Y. Okay. So this is triangle ADE that I copied from the original drawing. In triangle ADE, those two angles are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle there are equal sides. So in front of this angle we have side DE, and in front of this angle we have side AE. And according to the rule that I mentioned, side AE must be equal to side DE. Why? Because those two sides are located in front of equal angles, therefore they are also equal to each other. But side DE equals to x plus y, so you can write down that side DE equals to x plus y, and from this equation A equals to DE equals to x plus y, we will derive that side AE is also equals to x plus y. Side AE is also equals to x plus y. Okay. In the next step, I'll copy triangle ABE in this page, and we'll analyze triangle ABE. Side AB equals to x plus y according to what is given as the equation. We just right now found out that side AE equals to also x plus y. Angle ABE equals to theta. And we only found out that angle AEB equals to 20 degrees. So this is triangle ABE that I copied from the original drawing. In this triangle ABE, those two sides are both equal to x plus y, therefore they are equal to each other. That is to say, side AB equals to side AE. Side AB equals to side AE. And we have the rule that in front of equal sides in the triangle there are equal angles. In front of this side, side AB, we have this angle that is equal to 20 degrees. And in front of this side, side AE, we have this angle that is equal to theta. And those two angles must be equal to each other. Why? Because they are located in front of the equal sides AE and BE. Therefore, theta equals to 20 degrees. I repeat again, those two angles must be equal to each other. Why? Because they are located in front of equal sides, therefore they also must be equal to each other. So angle theta equals to 20 degrees. So we finish with the first method. In the next step I will present to you the second method. So in the second method, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. So the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So the sum of those two angles in the triangle is 120 degrees. Therefore, the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Okay, so this angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC, to 180 degrees. In the next step, we'll define side AD as A. and I will present to you the law of sines, and we will implement the law of sines in triangle ADC and then in triangle ABD. So first of all, I will present to you the law of sines. The law of sines is true in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. Side BC equals to A units. Angle BAC equal in its size to capital A degrees. Side AC equals to B units. And the angle ABC equals to capital B degrees. And finally, side AC equals to C units in its length. And the size of angle ACB, this angle, it is equal to C, to capital C degrees in its size. Okay, so here, according to the law of sines, we will get that A over sine A equals to B over sine B, and it is equal also to C over sine C. Okay, I repeat again, according to the law of sines, in this triangle ABC, A over sine A equals to B over sine B equals to C over sine C. Now we will implement the law of sines in triangle ADC. And repeat again, we will implement the law of sines in the green triangle ADC. Okay. So in the green triangle ADC, according to the law of sines, we get that DC over sinus 60 degrees equals to AD over sinus 40 degrees and it is equal to AC over sinus 80 degrees. I repeat again, in the green triangle ADC, according to the law of sines, we get that DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. So this is actually question number 1, is the implementation of the law of sines in this green triangle ADC. Okay, so here AD equals to A, therefore we substitute AD by A, and we get that A over sinus 60 degrees equals to actually we have DC equals to X, so we substitute DC by X. AD equals to A, so we substitute AD by A, and we get that A over sinus 40 degrees equals to AC equals to Y, so we substitute AC by Y. I repeat again. Here we substituted DC by X, we substituted AD by A, and we substituted AC by Y. So we have three expressions that they are all equal to each other. So we will define the value of the three expressions as K. We can do it because all the three expressions are equal to each other. Okay. So here we will derive the first equation from this long equation. The first equation will be that those two expressions are equal to each other. That is to say, X over sinus 60 degrees is equal to K here we multiply this equation number 1 by sinus 60 degrees, and we get that according to equation number 1, X equals to K times sinus 60 degrees. Okay. We will derive the second equation from this long equation. Here, those two expressions are also equal to each other, so I can write down that A over sinus 40 degrees equals to K here we multiply this equation number 2 by sinus 40 degrees, and we get that according to equation number 2, A equals to K times sinus 40 degrees. And finally, those two expressions are also equal to each other, so this will be equation number 3, that Y over sinus 80 degrees is equal to K Here we multiply this equation number 3 by sinus 80 degrees. And we get that according to equation number 3, y equals to k times sinus 80 degrees. So we actually have the values of x, y, and a in 3 equations, and in the next step we will implement the law of sines in this triangle ABD, but first of all ABC is a triangle, therefore BC is one side of triangle ABC, therefore it is absolutely a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So this angle equals to 80 degrees. So this angle must be equal to 100 degrees in order to complete the sum of the angles on one side, on the upper side of the straight line BC to 180 degrees. This angle must be equal to 100 degrees. Okay. So in the next step, we will implement the law of sines in the orange triangle ABD. So in the orange triangle ABD, according to the law of sines, here AD over sinus theta must be equal to, according to the law of sines, to AB over sinus 100 degrees. I repeat again, in the orange triangle ABD, according to the law of sines, AD over sinus theta must be equal to AB over sinus 100 degrees. So here AD equals to A, so we substitute AD by A, and we'll get that A over sinus theta equals to AB equals to x plus y, therefore we'll substitute AB by x plus y, so it is AB, that is x plus y, over sinus 100 degrees. So according to equation number 2, we found out that A over sinus theta equals to x plus y over sinus 100 degrees. In the next step, we substitute A, x, and y by the values that we found for them. Here, y equals to k sinus 80 degrees, and a equals to k sinus 40 degrees, and x equals to k sinus 60 degrees. So we substitute a, x, and y by the values that I mentioned here. Okay, so we get that according to equation number 2, here a is equals to k times sinus 40 degrees over sinus theta, and it is equal to x plus y. X is k times sinus 60 degrees plus y, and y is k times sinus 80 degrees all divided by sinus 100 degrees. So here we have k on both sides of the equation, so k will get cancelled. What is there from equation number 2 after we cancelled k? Here we have sinus 40 degrees over sinus theta is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Okay, so here we cross multiply this equation number 2, and we get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. So here we divide the equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 60 degrees plus sinus 80 degrees. Actually, we have the trigonometric identity that sinus 2a equals to 2 times sinus a times cosine a. We use this trigonometric identity for sinus 40 degrees. And we get that sinus 40 degrees is equal to sinus 2 times 20 degrees and according to this trigonometric identity that sinus 2a equals to 2 sine a cosine a, we get that sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay. So here we found out that sinus 40 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 40 degrees in equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. But before that, I present to you another trigonometric identity that states that sinus 90 degrees plus theta equals to cosine theta. We will use this trigonometric identity for sine 100 degrees. Actually, sine 100 degrees equals to sine 90 degrees plus 10 degrees, and sine 90 degrees plus 10 degrees, according to the trigonometric identity that sine 90 degrees plus theta equals to cosine theta, we will get that sine 90 degrees plus 10 degrees equals to cosine 10 degrees. Okay, so in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. Okay, so we can substitute sinus 100 degrees in equation number 2 by cosine 10 degrees. We will do it now, and we will also substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. And we will get that according to equation number 2, sinus theta equals to sinus 40 degrees, but we already found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, we substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. And according to equation number 2, sinus 40 degrees times sinus 100 degrees. So we substitute sinus 100 degrees by cosine 10 degrees. And according to equation number 2, we have to divide all by sinus 80 degrees plus sinus 60 degrees. Okay. Actually, we have another trigonometric identity for sinus 80 degrees plus sinus 60 degrees according to the following trigonometric identity: sinus D plus sinus C equals to 2 times sinus D plus C over 2 times cosine D minus C over 2. Okay, so we use this trigonometric identity for sinus 80 degrees plus sinus 60 degrees. And we get that sinus 80 degrees plus sinus 60 degrees, according to this trigonometric identity, will be equal to 2 times sinus D plus C is 80 plus 60 is 140, and 140 over 2 is 70 degrees, times cosine D minus C. D is 80, C is 60, and so 80 minus 60 is 20, and 20 over 2 is 10 degrees. Okay, so actually I found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. We'll do it now, and we get that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sine 80 degrees plus sine 60 degrees, but we already found out that according to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Okay. So here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. Here we have 2 cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. What is left from equation number 2 after we cancel the two expressions? Here we have, according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Okay, here we have the last trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta and what is the value of sinus 70 degrees? The value of sinus 70 degrees, it is equal to sinus 90 degrees minus 20 degrees, and according to the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we'll get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees is equals to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. We'll do it now, and we'll get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, but we already found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we substitute sinus 70 degrees by cosine 20 degrees in equation number 2, and we get that according to equation number 2, we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we left only with according to equation number 2, we found out that sinus theta equals to sinus 20 degrees, and we know that if sinus alpha equals to sinus beta, it means that alpha equals to beta. Therefore, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So we found out in the second method also that the size of angle theta is 20 degrees. We finished with the second method. In the next step, I'll summarize the lecture. We'll start with the first question, of course. the drawing we have a quarter circle. Line segment BC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units, angle OBC equals to 90 degrees, this angle BCD equals to 90 degrees, and this angle CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so first of all, we did the construction, we extended the straight line CD by straight line until it touches side OF by point M, but before that, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle, angle BOM equals to 90 degrees, and side AO equals to side OF, and those both sides are the radii of the quarter circle. We define the radii of the quarter circle as R, therefore AO will be equal to R and OF must be also equal to R. Okay, and then we did the construction, we extended the straight line CD by straight line until it touches the side OF at point M. So point M is the starting point of the extended straight line CD and OF. Okay, by doing this construction, we actually created quadrilateral BCOM, and inside quadrilateral BCOM we have 1, 2, 3 right angles, and we know that the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle CMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle CMO equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay? So I actually found out that this angle is a right angle, it is equal to 90 degrees. Therefore, actually, in quadrilateral BCOM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So repeat again, quadrilateral BCOM is a rectangle because of the fact that it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle BCOM must be equal to each other. That is to say, BC must be equal to OM. BC must be equal to OM, but it is given as the equation that BC equals to 9 units. So we can write here that BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. Here side OM equals to 9 units. Then, actually, here, when we extended the straight line CD by straight line, we got line segment CM. When you extend the straight line by straight line, the result must be a straight line. So the result that is CM must be a straight line. Therefore, CM is a straight line, and we have rule number 3 that the sum of the angles on one side of the straight line is equal to 180 degrees. We can implement rule number 3 here. So if we focus on this side, on the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have angle, this angle that is equal to 90 degrees plus angle LDM. Okay, so here 90 degrees plus angle LDM must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation, and we found out that the missing angle LDM equals to 90 degrees. So this angle LDM equals to 90 degrees. Likewise, we know that OF is the radius of the quarter circle. OF is the radius of the quarter circle, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line OF at point M, the sum of the angles here must be equal to 180 degrees. So which angle we have? which angles we have in the upper side of OF at point M. We have here 90 degrees plus angle DMN or DMF. So 90 degrees plus angle DMF must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and we found out that the missing angle DMF, this angle equals to 90 degrees. Okay, then from point L we draw perpendicular on OF. So this angle equals to 90 degrees according to our construction. By drawing this perpendicular, we actually created quadrilateral LDMN, and inside quadrilateral LDMN we have 1, 2, 3 right angles. Okay, I repeat again, inside quadrilateral LDMN we have 3 right angles, and the sum of 3 right angles is 270 degrees plus the size of the fourth angle, that is actually angle DLN, this angle. In total, that must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle DLN equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So here the missing angle DLN equals to 90 degrees, therefore we found out that actually in quadrilateral DLMN we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral DLMN as a rectangle. Okay, repeat again, quadrilateral DLMN is a rectangle. Why? Because it has 4 right angles. Okay? And we also know that the opposite sides of rectangle are equal to each other, so the opposite sides of rectangle DLMN are equal to each other. Okay, we define side DM as edge. So in rectangle DLMN, its opposite sides are equal to each other. That is to say, side DM equals to side LN. Side DM equals to side LN, but according to our definition, DM equals to edge. And from this equation, edge equals to DM equals to LN, we will derive that side LN is also equals to edge. Here, side LN is also equals to H. Okay? Likewise, according to the same rule that the opposite sides of rectangle are equal to each other, so in rectangle LDMN, side DL must be equal to side MN. Side DL must be equal to side MN, but here, according to what is given as the equation, DL equals to 12 units. So we can write here that DL equals to 12, and from this equation 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Here side MN equals to 12 units. So actually we found out that the length of side ON is OM plus MN, that is 9 plus 12 is 21 units. And because of the fact that points N and F are very close to each other, it means that the radius of this circle that is equal to OF must be very close to 21 units. A little bit longer than 21 units because ON equals to 21 and point F is very close to point N. So we are expecting to find the radius that is a little bit longer than 21 units. Okay? So in the next step we join points O and C together by straight line. And here point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R. Then we implemented the Pythagoras theorem on the right green triangle, triangle OCM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the surface of the perpendiculars. That is to say, OC square equals to OM square plus MO square. Repeat again, the right green triangle, triangle OCM. OC square equals to OM square plus CM square. OC equals to R, therefore OC square is R square. OM equals to 9, therefore OM square is 9 square, that is 81. And what is the value of CM? CM is CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is H. In total, CM equals to 16 plus H. So cm equals to 16 plus h, therefore cm square is 16 plus h square. So in conclusion, we found out that r square equals to 81 plus 16 plus h square. We opened the brackets on this side of equation number 1 and found out that according to equation number 1, r square equals to 81 plus 16 plus h square. 16 plus h square is 16 square, that is 256, plus h square plus 2 times 16 times h, that is 32h. So here, according to equation number 1, r square equals to 81 plus 256 is 337, plus h square plus 32h. So according to equation number 1, we found out that r square equals to 337 plus h square plus 32h. Then we focus on the orange triangle, triangle O and N. Actually, we joined points O and N together by a straight line. Point O is the center of the quarter circle, point N is the point of the quarter circle itself, therefore ON is the radius of this quarter circle. Then we implemented the Pythagoras theorem on the right orange triangle, triangle O and N. According to the Pythagoras theorem, OL square equals to OLN square plus NO square. I repeat again, the right triangle O and N, OLO square equals to OLN square plus NO square. NO equals to R, therefore NO square is R square. Ln equals to h, therefore ln square is h square. No equals to 9 plus 12, it is 21, therefore no square will be equal to 21 square. So in conclusion, we found out that r square equals to h1 plus 21 square. 21 square is 441, therefore we wrote it down that r square equals to h1 plus 441. So we have two different expressions for r squared, therefore we created equation number 3 that states that r squared according to equation number 1 must be equal to r squared according to equation number 2. And r squared according to equation number 1 is equal to 337 plus h squared plus 32h, and it must be equal to r squared according to equation number 1, that is h squared plus h squared plus 441. Here we have h squared on both sides of the equation, so h squared will get cancelled. So what is left from equation number 2 of the cancelled h squared? In this side of the equation we have 337 plus 32h, that is equal to 441. Here we subtracted 337 from this equation number 3, and we found out that according to equation number 3, 32h equals to 441 minus 337 is 104. So in conclusion, we found out that according to equation number 3, 32h equals to 104. Here we divided this equation number 3 by 32, and we found out that h equals to 104 over 32. 104 over 32 is 3.25. So we found out that h equals to 3.25. Now we can substitute h in equation number 2 by 3.25. We did it, and we got that according to equation number 2, r squared equals to h squared plus 441. So if h equals to 3.25, it means that h squared will be equal to 3.25 squared. That is equal to 10.5625. So according to equation number 2, we found out that r squared equals to 10.5625 plus 441. That is to say, r squared equals to 451.5625. We took out of this equation and found out that the square root of 451.5625 it is equal to 21.25 units. Okay, so the answer to the question that r equals to 21.25 units. We finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So in the drawing we have triangle ABC. Side AB equals to x plus y, side AC equals to y, side DC equals to x. This angle equals to 40 degrees, this angle equals to 80 degrees, and our mission is to find out the size of this angle, angle theta. So in the first method we did the construction, we extended side BC by y units, that is to say CE equals to y units. Then we joined points A and D together by a straight line. and by joining points A and D by straight line, we created the triangle ACE, so I copied triangle ACE in a new page and analyzed triangle ACE. This is triangle ACE that I copied from the original drawing. AC equals to Y according to what is given as the equation, and C equals to Y according to our construction. So those two sides are both equal to Y, therefore they are equal to each other. That is to say, side AC equals to side CE, and you know that in front of equal sides in the triangle there are equal angles. Those two sides are located in front of those two angles, therefore those two angles must be also equal to each other. So if one angle equals to alpha, then the other angle must be also equal to alpha. And then I copied angle ACB in this drawing from the original drawing, and then I presented to you the external angle theorem. According to the external angle theorem, here the external angle E equals to alpha plus beta. That is the sum of the two internal angles that are not adjacent to it. We implemented the angle bisector theorem in our triangle ACE. According to the angle bisector theorem, the external angle ACB must be equal to alpha plus alpha, that is 2 alpha. Okay? So, but according to what is given as the equation, angle ACB equals to 40 degrees. So, we can write here that angle ACB equals to 40 degrees. Therefore, in conclusion, we found out that 40 degrees equals to alpha plus alpha, that is 2 alpha. So, if 40 degrees equals to alpha, it means that alpha equals to 20 degrees. So here alpha equals to 20 degrees, and here also alpha equals to 20 degrees. Then I copied the right triangle ADE in a new page, and we'll analyze triangle ADE. This is triangle ADE that I copied from the original drawing. But first of all, we just right now found out that this angle alpha equals to 20 degrees, and this angle that is alpha is also equals to 20 degrees. Therefore, angle DAE will be equal to 20 degrees plus 60 degrees, that is 80 degrees. This angle equals to 80 degrees, and this angle equals to 80 degrees according to what is given as the question. What is the length of side DC, side DE? DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. So we can write here that DE equals to X plus Y. So those two angles are both equal to 80 degrees, and we have the rule that in front of equal angles in the triangle there are equal sides. So in front of this angle we have side DE, and in front of this angle we have side AE, and according to the rule that I mentioned, side AE must be equal to side DE because they are located in front of equal angles. But according to what we have already found out, that DE equals to X plus Y. So we can write here that DE equals to X plus Y. And from this equation we will get that AE equals to D equals to XY. We will derive that side AE is also equals to X plus Y. Here side AE equals to X plus Y. And then I copied the big triangle ABE in this page, and we analyze triangle ABE. AE equals to X plus Y, according to what we concluded just right now. Side AB equals to X plus Y according to what is given as the equation. Angle ABE equals to theta according to what is given as the equation. And we have already found out that this angle equals to 20 degrees. So triangle ABE is an isosceles triangle because those two sides are equal to each other. So here, because of the fact that both sides are equal to X plus Y, it means that those two sides are equal to each other. That is to say, side AB equals to side AE. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side, side AB, we have 20 degrees. In front of this side, side AE, we have angle theta. And according to the rule that I mentioned, those two angles must be equal to each other because of the fact that they are located in front of equal sides. Okay, so actually arrive to the conclusion that the size of angle theta, the angle that we are looking for, is equal to 20 units. We finish with the first method, then I presented to you the second method. In the second method, we did here we focus on triangle ADC, In triangle ABC, this angle equals to 80 degrees, this angle equals to 40 degrees. In total, the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So if the sum of the two angles in a triangle is 120 degrees, it means that the third angle must be equal to 60 degrees in order to complete the sum of the angles in the triangle to 180 degrees. The third angle must be equal to 60 degrees. So this angle equals to 60 degrees. Then we define side AD as A, and then I presented to you the law of sines, and we implemented the law of sines in the green triangle and also in the orange triangle. What is the law of sines? In this triangle, triangle ABC, here A over sine A equals to B over sine B equals to C over sine C. We implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, we get that DC over sinus 60 degrees equals to AD over sinus 40 degrees, and it is equal to AC over sinus 80 degrees. Okay, then AD equals to A, AC equals to Y, and DC equals to X. So we substitute AD by A, AC by Y, and DC by X, and we got this equation. And because of the fact that those three expressions are equal to each other, we can define that the value of all of them, the value of each of them is equal to K. Then from this long equation, we derive that those two expressions are equal to each other, that is to say x over sinus 60 degrees equals to K. We multiply this equation by sinus 60 degrees and found out that x equals to K times sinus 60 degrees. Then we derived from this long equation that those two expressions are also equal to each other, that is to say here A over sinus 40 degrees equals to K. We multiply this equation by sinus 40 degrees and found out that A equals to K times sinus 40 degrees. And finally, those two expressions are also equal to each other. That is to say, according to equation number 3, y over sinus 80 degrees equals to K. We multiply this equation by sinus 80 degrees and found out that y equals to K times sinus 80 degrees. So we have expressions for the value of x, y, and A. Then we implemented the law of sines in the orange triangle, triangle ABD. But before that, we know that BC is a straight line. This angle equals to 80 degrees. Therefore, in order to complete the sum of the angles on the upper side of the straight line BC to 180 degrees, this angle must be equal to 100 degrees. Then we implemented the law of sines in the orange triangle, triangle ABD. According to the law of sines, we get that AB over sinus 100 degrees must be equal to AD over sinus theta. I'll repeat again. AD over sinus theta equals to AB over sinus 100 degrees. Here AD equals to A, so we substitute AD by A. AB equals to x plus y, and therefore we substitute AB by x plus y. We got this equation, A over sinus theta equals to x plus y over sinus 100 degrees. Then we substituted A by K times sinus 40 degrees. We substituted x by K times sinus 60 degrees, and we substituted y by K times sinus 80 degrees. When you got this equation number 2, then we have K on both sides of the equation, so K will get cancelled. What is left from equation number 2 of the cancel 2? What is left? It is actually sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2, and found out that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Here we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 60 degrees plus sinus 80 degrees. Here we have the trigonometric identity that sinus 2a equals to 2 sine a cosine a. We use this trigonometric identity for sinus 40 degrees. Sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Then we use the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta for sinus 100 degrees. Sinus 100 degrees is equal to sinus 90 degrees plus 10 degrees. And here, so, and according to the trigonometric identity, the trigonometric identity that sinus 90 degrees plus theta equals to theta, we get that the value of sinus 90 degrees plus 10 degrees according to this trigonometric identity must be equal to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. Therefore, we can substitute sinus 100 degrees in equation number 2 by cosine theta, and we can also substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. Actually, we did it. We substituted the two expressions, and we got that sinus theta equals to, we substituted sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees, and we substituted sinus 100 degrees by cosine 10 degrees, and all divided by sinus 80 degrees times plus sinus 60 degrees. Then we have the trigonometric identity that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We use this trigonometric identity for sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus d plus c. D is 80, c is 60, 80 plus 60 is 140, and 140 over 2 is 70, times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 20 degrees. Therefore, we can substitute cosine 80 degrees plus sine 60 degrees by 2 sine 70 degrees cosine 10 degrees. Actually, we did it, and we found out that according to equation number 2, 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, here it is over sinus 60 degrees plus sinus 80 degrees, and we substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will we get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, found out that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. And finally, we have the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. And we know that sinus 70 degrees equals to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we'll get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 20 degrees by cosine 20 degrees. Actually, we did it, and we got that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sine 70 degrees, and we substituted sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. And we left only with sinus theta that is equal to sinus 20 degrees, and if sinus alpha equals to sinus beta, it means that alpha equals to beta. Therefore, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the side of this angle theta, is equal to 20 degrees. Okay, thank you very much.